Yes, I understand. I'm on my way now.
For most of the 20th century, human communication was tied to fixed locations. Telephones existed, but they were anchored to homes, offices, factories, and public booths. Communication was place-based rather than person-based. To receive a call, one had to be physically present at a specific location. If a person moved, communication stopped. This limitation shaped daily life, work habits, and even social expectations. Being reachable meant being stationary. Landline telephones relied on extensive physical infrastructure, copper wires, exchanges, and switching systems. While they enabled real-time voice communication, they imposed rigidity. Business decisions were delayed when key people were unavailable. Emergencies depended on proximity to a phone. Coordination across cities or within large organizations required advanced planning. Human mobility steadily increased through cars, urban expansion, and faster lifestyles, yet communication technology lagged behind this reality. Attempts to overcome this limitation existed but were incomplete. Two-way radios allowed communication without wires, but they were restricted to specific users and did not support private, full-duplex conversations. Messages were often broadcast rather than personal. Privacy, clarity, and scalability were major challenges. The human voice could travel wirelessly, but not in a way that matched everyday conversational needs. As societies became faster and more interconnected, the mismatch grew clearer. People moved constantly between meetings, cities, and roles, while communication systems remained static. The core problem was not the absence of voice technology, but the absence of personal mobility in communication. Solving this problem required a fundamental shift. Communication needed to follow the person, not the place. This unmet need defined the environment in which the mobile phone would eventually emerge. Before handheld mobile phones, the most advanced form of mobile communication was car-based telephony. These systems appeared promising on the surface. Phones installed in vehicles could connect to wireless networks, allowing drivers to make calls while moving. However, the technology was deeply constrained. Equipment was bulky, power-hungry, and expensive. Most systems supported only a small number of simultaneous users within a city. Technically, early mobile systems relied on high-powered transmitters covering large areas. This meant limited channel capacity. In many cities, only a few dozen users could place calls at the same time. Access was tightly controlled and typically reserved for government officials, emergency services, or corporate executives. For the general public, such systems were impractical and inaccessible. From a usability standpoint, these systems failed to solve the core problem. Communication was still tied to a vehicle, not a person. Leaving the car meant losing connectivity. Calls were often unreliable, plagued by interference and dropped connections. Setup times were long, and switching between coverage areas was inefficient or non-existent. Equally important was the conceptual limitation. The telecommunications industry largely viewed wireless telephony as an extension of landlines, not a replacement. The goal was to make phones portable enough for vehicles, not truly personal. Engineers focused on scaling existing models rather than rethinking communication from first principles. This mindset prevented broader innovation and delayed the realization that true mobility required smaller devices, smarter networks, and a different architectural approach. The idea of a handheld, personal mobile phone challenged deeply held assumptions. Many engineers believed such a device was unrealistic. Batteries were heavy, electronics were power-intensive, and radio spectrum was limited. Critics argued that a portable phone would be too large, too short-lived, or too unreliable to be practical. Others questioned demand. Why would ordinary people need to talk while moving? The conceptual breakthrough came from redefining what communication was meant to do. Traditional telephony connected locations. Mobile communication needed to connect individuals. This distinction changed everything. If the user, not the infrastructure, became the center of the system, design priorities shifted. Devices had to be small enough to carry, networks flexible enough to track movement, and capacity sufficient for mass adoption. This redefinition also reframed spectrum usage. Instead of a few powerful transmitters covering large regions, communication could be divided into smaller geographic cells, each reusing frequencies efficiently. This approach promised scalability rather than exclusivity. It suggested that millions of users could share limited spectrum without interference, provided the system was designed intelligently. Skepticism remained strong, particularly within established telecom institutions. Existing investments favored centralized, high-power systems. A personal mobile phone threatened established business models and regulatory frameworks. Yet the logic was compelling. Human communication is personal, immediate, and continuous. A technology that mirrored these traits would not merely improve communication, it would transform it. The first public demonstration of a handheld mobile phone marked a turning point. It proved that personal, portable voice communication was technically feasible. The device was heavy by modern standards, battery life was limited, and call quality was basic. Yet the essential requirement had been met. A person could place a call while walking freely without wires or vehicles. Acceptance was gradual rather than immediate. Early mobile phones were expensive, networks were sparse, and coverage was limited. However, the value proposition was clear. Mobility eliminated delays, improved coordination, and expanded communication into contexts previously unreachable. Over time, infrastructure expanded, devices shrank, and costs declined. The cellular model enabled exponential growth. By dividing regions into cells and reusing frequencies, networks scaled to serve entire populations. Advances in electronics, batteries, and signal processing accelerated adoption. What began as a technical experiment evolved into essential infrastructure. The ultimate success of the mobile phone lay in alignment with human behavior. People move constantly, and communication that adapts to movement feels natural. The mobile phone did not require users to change how they spoke or thought. It extended existing communication habits into new environments. By solving a problem rooted in everyday experience, the need to stay connected while mobile, the mobile phone reshaped business, emergencies, social interaction, and global culture. Its success was not accidental or sudden. It was the result of recognizing that communication technology must follow people, not places. Martin Cooper was born in 1928 in Chicago, Illinois, into a world shaped by rapid industrial and technological change. His early years unfolded during a period when electricity, radio, and mass production were transforming everyday life in the United States. Unlike earlier generations, Cooper grew up in an environment where technology was not distant or abstract. It was present in homes, factories, and public infrastructure. This exposure created a natural familiarity with engineered systems rather than a sense of awe or intimidation. Cooper's family environment emphasized practicality and problem-solving. From a young age, he showed curiosity about how things worked rather than simply how they were used. Radios, electrical appliances, and mechanical devices attracted his attention not as finished products, but as systems with internal logic. He was inclined to disassemble objects, examine their components, and reassemble them, often with improvements or modifications. This habit of inquiry laid the foundation for an engineering mindset focused on function rather than appearance. Importantly, Cooper grew up during a time when communication technologies were becoming central to national life. Radio connected households to news and entertainment. Telephones linked homes and offices. These technologies were visible reminders that engineering could reshape human interaction. Cooper absorbed this context intuitively. Communication was not merely a social activity, it was a technical challenge that could be improved. Rather than being driven by early ambition to invent something specific, Cooper developed a broader orientation toward systems thinking. He learned to view technology as a tool for solving real-world problems, not as an end in itself. This perspective would later distinguish his approach to mobile communication, which focused on human needs rather than incremental technical refinement alone. Cooper's formal education reflected both discipline and adaptability. After completing his early schooling, he pursued higher education in electrical engineering, a field that combined theoretical rigor with practical application. Electrical engineering in the mid-20th century was a demanding discipline, grounded in mathematics, physics, and circuit theory. It required precision, patience, and a strong grasp of abstract principles. His university training provided a structured understanding of signal transmission, electromagnetic theory, and electronic systems. These subjects formed the technical backbone of all later work in telecommunications. Cooper learned how electrical signals behave, how interference arises, and how systems can be optimized for reliability and efficiency. Unlike informal experimentation, academic training imposed standards of proof and reproducibility, sharpening his analytical skills. Equally important was exposure to systems-level thinking. Engineering education emphasized integration, how individual components interact within a larger whole. Communication systems, in particular, were not isolated devices, but networks involving transmitters, receivers, infrastructure, and users. This holistic view later became essential when Cooper confronted the complexity of mobile networks. Cooper's education did not isolate him from practical concerns. Engineering programs of the era maintained close ties with industry, reinforcing the idea that theoretical knowledge existed to solve concrete problems. This balance between abstraction and application prepared him to work effectively in large technological organizations while retaining the confidence to challenge established approaches. Following his formal education, Cooper entered the telecommunications industry at a time when innovation was accelerating but still constrained by existing models. Early in his career, he worked on wireless communication systems related to defense and public safety. These roles exposed him to the realities of radio communication under demanding conditions, limited bandwidth, interference, and the need for reliability. This experience was formative. Cooper saw firsthand how wireless systems functioned in real environments rather than controlled laboratory settings. He learned that successful communication technology had to be robust, adaptable, and user-centered. Systems that worked theoretically but failed in practice were of limited value. As Cooper advanced professionally, he took on increasing responsibility for system design and strategic planning. He developed expertise not only in hardware, but in how communication systems were deployed and managed. This broader perspective allowed him to recognize structural limitations in existing wireless approaches. Large, centralized transmitters and restricted access models could not scale to meet future demand. Crucially, Cooper's career placed him at the intersection of engineering and decision-making. He was not isolated as a technical specialist. He participated in shaping long-term technological direction. This role required balancing innovation with feasibility, cost, and regulatory constraints. It also required confidence to propose ideas that challenged dominant assumptions, a skill Cooper developed gradually through professional experience rather than sudden inspiration. Cooper's personal life contributed to the stability necessary for sustained innovation. Like many engineers of his generation, he valued discipline, routine, and long-term thinking. These traits supported work on complex problems that could not be solved quickly or in isolation. Developing new communication systems required persistence over years, not moments of brilliance. Marriage and family life provided grounding outside the professional sphere. This balance reduced dependence on external validation and allowed Cooper to approach work methodically rather than reactively. He was known for maintaining clarity under pressure and for focusing on objectives rather than recognition. These qualities were essential when proposing ideas that ran counter to prevailing industry views. Importantly, Cooper did not see technology as separate from everyday life. His personal and professional worlds reinforced one another. Observing how people lived, moved, and communicated informed his understanding of technological shortcomings. Communication systems were judged not by elegance alone, but by how well they fit into real human routines. By the time Cooper began pursuing the concept of a personal mobile phone, his character and expertise were fully formed. He possessed deep technical knowledge, practical industry experience, and a stable personal foundation. This combination positioned him to recognize a fundamental truth others overlooked. Communication technology had to adapt to human mobility, not constrain it. The mobile phone would emerge not from isolated genius, but from a life shaped by disciplined thinking, systems awareness, and attention to how people actually live and communicate. By the late 1960s and early 1970s, the telecommunications industry stood at a crossroads. Wireless communication existed, but its role was narrowly defined. Most industry leaders viewed mobility as a specialized feature rather than a universal requirement. The prevailing vision centered on car-based telephony and large, centralized radio systems. These systems treated wireless access as an extension of landline networks, not as a fundamentally different mode of communication. Within this environment, different companies pursued different strategies. Some focused on expanding vehicle-mounted phone services, assuming that mobility meant communication tied to transportation rather than to individuals. Others invested in improving infrastructure efficiency without questioning whether the underlying model was appropriate for future demand. The emphasis remained on limited users, high-cost devices, and tightly controlled access. Martin Cooper recognized a deeper issue. From his perspective, the industry was solving the wrong problem. The question was not how to make phones work better in cars, but how to make communication personal and ubiquitous. Cooper understood that as societies became more mobile, communication systems would need to reflect that mobility at the individual level. A system designed around vehicles could never scale to serve entire populations. This insight set Cooper's thinking apart. He saw wireless communication not as a luxury or supplement, but as a necessity that would eventually match or exceed landline usage. To achieve this, the entire architecture, devices, networks, and spectrum management would need to change. The journey toward the mobile phone began with this conceptual departure, rejecting place-based communication in favor of person-based connectivity. Turning the idea of a handheld mobile phone into reality presented significant technical challenges. At the time, electronic components were relatively large and power-intensive. Batteries capable of supporting sustained radio transmission were heavy and inefficient. Antennas required careful design to function effectively in compact devices. Each of these constraints reinforced skepticism about feasibility. Cooper approached these challenges systematically. Rather than attempting to perfect each component in isolation, he focused on defining acceptable trade-offs. The device did not need to be elegant or long-lasting at first. It needed to prove the concept. Weight, size, and battery life could improve over time. What mattered initially was demonstrating that personal, portable voice communication was possible without reliance on vehicles or fixed infrastructure. Network design posed an even greater challenge. A handheld phone could not rely on high-powered transmitters without draining batteries quickly and causing interference. The solution lay in cellular architecture, dividing service areas into smaller cells, each with its own base station, and reusing frequencies efficiently. While the cellular concept existed in theory, implementing it for personal devices required new assumptions about user density, mobility, and handoff between cells. Engineering progress was incremental. Prototypes were built, tested, modified, and rebuilt. Problems such as signal clarity, interference, and power consumption were addressed through iterative refinement rather than sweeping redesigns. Cooper's leadership emphasized practicality over perfection. Each improvement moved the system closer to viability, even if the device remained crude by later standards. The defining milestone in Cooper's journey occurred in 1973, when the first public handheld mobile phone call was successfully made. This event was not staged as a dramatic spectacle, but as a technical demonstration. Its purpose was to show that personal, portable wireless communication worked outside of vehicles and fixed locations. The device used was large and heavy by modern standards, weighing over a kilogram and offering limited talk time. Yet it fulfilled its essential function. A user could hold the phone, dial a number, and speak clearly while moving freely. This alone distinguished it from all previous wireless systems. From an engineering standpoint, the call validated several critical assumptions. First, handheld devices could transmit and receive voice signals with sufficient clarity. Second, battery-powered operation was viable, even if limited. Third, the network could support real-time communication without centralized, high-power transmitters. Equally important was the symbolic impact within the industry. The demonstration challenged entrenched beliefs about what wireless communication could be. It forced competitors, regulators, and engineers to reconsider long-held assumptions. The question was no longer whether personal mobile phones were possible, but how quickly they could be developed and deployed at scale. The call marked a transition from theory to proof. While significant work remained, the conceptual barrier had been broken. Communication no longer needed to be tied to place or vehicle. It could be carried by the individual. After the initial demonstration, Cooper's focus shifted from validation to implementation. A single working device did not constitute a usable system. Commercial success required regulatory approval, standardized frequencies, infrastructure investment, and mass production. Each of these steps involved negotiation, planning, and compromise. Regulatory challenges were substantial. Radio spectrum was tightly controlled, and allocating frequencies for widespread personal use required policy changes. Cooper and his colleagues engaged with regulators to demonstrate that cellular systems could manage interference and scale responsibly. These discussions were as critical as technical development, shaping how mobile networks would grow. Within the industry, resistance gradually gave way to acceptance. The advantages of personal mobility became undeniable as prototypes improved and network designs matured. Competitors adopted similar approaches, accelerating innovation. What had begun as a challenge to conventional thinking evolved into a new industry standard. Cooper's journey to the mobile phone illustrates how transformative technologies emerge. Success did not result from a single invention or isolated insight. It arose from sustained effort, conceptual clarity, and willingness to challenge existing models. Cooper did not merely improve wireless telephony. He redefined its purpose. By placing the individual at the center of communication, he laid the groundwork for a global shift. The mobile phone would go on to reshape economies, social interaction, and access to information. Yet its origins trace back to a disciplined process of questioning assumptions, solving practical problems, and aligning technology with human movement. This journey demonstrates that lasting innovation depends as much on perspective as on technical skill. At its foundation, the mobile phone operates on a simple but powerful principle: converting human speech into electrical signals, transmitting those signals wirelessly, and then converting them back into sound at the receiving end. The complexity of mobile communication lies not in this basic idea, but in executing it reliably while the user is moving. Human speech consists of sound waves created by vibrating vocal cords. These waves vary continuously in frequency and amplitude, carrying information such as pitch, tone, and emphasis. Inside a mobile phone, a microphone captures these sound waves and converts them into an electrical signal. This signal mirrors the shape of the original sound waves, preserving the information needed to reconstruct speech. Once converted into electrical form, the signal must be prepared for wireless transmission. This involves modulation, a process that combines the voice signal with a higher frequency radio carrier wave. Modulation allows the signal to travel efficiently through space without interference from other signals. Early mobile systems used analog modulation, while modern systems use digital encoding, but the core idea remains unchanged. Speech must be translated into a form suitable for radio transmission. This process happens almost instantaneously. The user experiences it as natural conversation, unaware of the multiple transformations occurring in milliseconds. The elegance of mobile communication lies in this transparency. Technology adapts to human speech rather than requiring humans to adapt to technology. The defining technical innovation that enables mobile phones to scale is the cellular network. Instead of relying on a single powerful transmitter to cover a large area, the service region is divided into smaller geographic zones called cells. Each cell is served by a base station equipped with antennas and radio equipment. This architecture solves two critical problems: capacity and interference. By limiting the coverage area of each base station, the same radio frequencies can be reused in non-adjacent cells without causing interference. This concept, known as frequency reuse, allows a finite amount of radio spectrum to support millions of users simultaneously. When a mobile phone is active, it communicates with the nearest base station using assigned frequencies. As the user moves, the phone continuously measures signal strength from surrounding cells. Network control systems use this information to manage resources efficiently and maintain call quality. Cell size varies depending on population density and usage patterns. Urban areas use smaller cells to support higher user density, while rural areas use larger cells to maximize coverage. This flexibility allows mobile networks to adapt to real-world conditions, balancing capacity, coverage, and cost. The cellular model transformed wireless communication from a limited service into a mass technology. Without it, personal mobile phones would remain impractical due to spectrum constraints. One of the most technically demanding aspects of mobile communication is maintaining a connection while the user moves. This process is handled through a mechanism known as handoff or handover. As a user travels from one cell to another, the network must transfer the calls seamlessly between base stations. The mobile phone and the network work together to accomplish this. The phone continuously monitors signal strength and quality from nearby cells and reports this data to the network. When the current connection weakens and a stronger alternative is available, the network initiates a handoff. Ideally, this transition is completed without the user noticing any interruption. Handoffs require precise timing and coordination. If executed too early, network resources are wasted. If executed too late, calls may drop. Early mobile systems struggled with this balance, leading to frequent disconnections. Advances in signaling protocols and processing power gradually improved reliability. Beyond voice calls, mobility management also supports messaging and data services. Even when a phone is idle, the network tracks its approximate location, so incoming calls or messages can be routed correctly. This constant coordination enables the mobile phone to remain reachable across wide geographic areas. Mobility management distinguishes mobile communication from all earlier systems. It allows communication to persist despite movement, fulfilling the original goal of person-centered connectivity. While early mobile phones were limited in capability, the underlying technical framework proved remarkably adaptable. Analog systems gave way to digital standards, improving clarity, security, and capacity. Voice signals began to be encoded as digital data, allowing compression, error correction, and integration with other services. Despite these changes, the fundamental architecture remained consistent. Speech is still captured, transformed, transmitted, and reconstructed. Cells still divide geographic space. Networks still manage mobility and resource allocation. Each technological generation builds on these same principles, refining efficiency rather than replacing the core design. Modern smartphones extend this framework far beyond voice. Data transmission enables internet access, multimedia communication, and real-time navigation. Yet these services rely on the same cellular concepts established during the early development of mobile telephony. The lasting influence of the mobile phone lies in its systems-level design. It demonstrated that large-scale communication systems could be decentralized, adaptive, and user-centered. By aligning technology with human movement and behavior, mobile communication reshaped expectations of availability, responsiveness, and connectivity. Technically, the mobile phone represents a convergence of radio engineering, network theory, and human factors. Its success did not come from complexity alone, but from coherent integration. By treating communication as a dynamic process tied to individuals rather than locations, the mobile phone became one of the most influential technologies of the modern era, fulfilling the vision that communication should move with the person wherever they go.